Hello and welcome to How Do I Construct and Solve Equations Including Fractions and Powers, Part 2. On the screen we have at the moment a starter question, so if you'd like to pause the video, work out whether you decide whether these statements are always true, sometimes true or never true, and then press play and see if we get the same answers. Okay, x is smaller or equal to x squared. Is that always true, sometimes true, or never true? It is sometimes true. The reasons why it's sometimes true: if x is 0, then x squared is 0, so it's true. If x is 1, x squared is 1, because x squared is 1. However, if x is 2, then x squared is 4, so it's not equal. So it's sometimes true. Sometimes true, but only true when x is either 0 or 1. Next question. 3 bracket x plus 4 bracket equals 2x plus 12. Well, if you want to work out the brackets, we have 3 times x is 3x. 3 times 4 is 12. And we have 2x plus 12. So you can see that 3x plus 12 is not the same as 2x plus 12, so it's not always true. Would it ever be true? Yes, it would be true if x is 0. If x is 0, 3 times 0 is 0, plus 12 equals 2 times 0, which is 0, plus 12. So we end up with 12 plus 12. 12 equals 12. So it's sometimes true. Only when x is 0. 3x plus 4 equals 3x plus 12. Well, we know from the top one above it that 3x plus 12 equals 3x plus 12. So it's going to be always true. That statement is always going to be true. Next. X squared equals minus 6. X squared equals minus 6. Well, when you square a negative number, for example, minus 3 times minus 3, we end up with a positive. So x squared will never be minus 6. X plus 5 equals 12. X plus 5 equals 12. Well, it's not always true, because 1 plus 5 equals 6. It's never true, because 7 plus 5 equals 12, so it can only be sometimes true when x is worth 5. And for the last one, 5x is larger than 4x. Is that always true? Is that never true? Or is that sometimes true? Well, it's sometimes true, and the reason is if x is minus 1 or below, then we have 5 times minus 1, which is minus 5, and 4 times minus 1 is going to be minus 4. Is minus 5 bigger than minus 4? No. Minus 4 in that case will be bigger than minus 5, so that's only sometimes true. It's sometimes true when x is a positive number, but false when x is 0 or a negative number, so it's only sometimes true. Next question. Word example. Solve the equation x squared plus 9 x squared plus 9 equals 90, giving positive and negative solutions. So we subtract 9 from both sides to get rid of this. Minus 9 both sides. We have that x squared equals 81. Now, you get a calculator out really, unless you know your square numbers. X equals the plus or minus square root of 81. Because there are two answers to this. X equals either 9 or negative 9. Like I said before, two negatives multiplied together make a positive. So minus 9 times minus 1 with 81. And 9 times 9 is 81. So with this in mind, can you have a go at these questions? So pause the video, look at the answers. When you're ready, press play. So 10. X squared plus 5 equals 21. To get rid of the 5, minus 5 both sides. So end up with x squared equals 21 take away 5 is 16. So x equals the plus or minus square root 16. So x equals square root 16 is 4. So the other one, or minus 4. B. X squared plus 9 equals 58. Get rid of the 9 here, both sides. Just leave x squared on its own. X squared equals 58, take away 9. If I take 8 away, that's 50. Take 1 more, it'll be 49. X squared equals 49. So we want x equals the square root of 49. And we know it can be a plus or a minus. The square root of 49 is 7. 7 sevens are 49. Or minus 7 times minus 7 is 49. C. X squared minus 5 equals 95. To get rid of minus 5, we need to add 5 to both sides. So x squared equals minus 5 add 5 is nothing. 95 add 5, 100. So x equals the plus or minus the square root of 100. And we know that x would equals 10 or minus 10. D. X squared over 2 equals 32. To get rid of the divide by 2, you need to times everything by 2. You times this by 2, end up with x squared. So times by 2, times by 2. 32 times by 2 is 64. So then find x equals plus or minus the square root of 64. X could be 8 or minus 8. E. X squared plus 3 squared plus 4 squared. Pythagoras coming here. Equals x squared equals 3 squared plus 4 squared. X squared equals 3 squared, which is 9. 4 squared is 16. Adding these two numbers together, x squared equals 25. So x equals the plus or the minus the square root of 25. So x equals 5 or minus 5. F. X squared minus 5 squared equals 12 squared. Pythagoras again. X squared minus 5 squared is 25 equals 12 squared is 144. The opposite to a minus is a plus, and we're adding 25 both sides. So x squared equals 144, add 25, 169. So x equals the plus or the minus of the square root of 169. X equals 13 or minus 13. I said Pythagoras because these two here are one of the two triples. that you've learned recently. Question 7. I'll bring that all up a bit and we can see it a bit better. Pause the video, work out the answers, and I should then put it back to where it should be. Okay. Question 11. I have a square. It's x by x, and the area is 225. So this is x squared. X squared equals 225. So x equals plus or minus the square root of 225. So calculator. So the square root 225 equals 15. So x equals 15 or minus 15. Now, if we're using lengths, we wouldn't use a minus number, we just use 15. So the answer is 15. Okay. That's 1, 2, y and y, and a little box here, 1 by 4. Total area equals 200. Total area. We want to get rid of this because it's y squared. So y squared equals 200 minus 4, because that's not part of the y. So 200 minus 4, so y squared equals 200 take away 4 is 196. So y equals the square root 196. So the square root 196 equals 14. So y equals 14. 3. We have a box. I have a little box here. This is 1 by 4. This is z by z. Green area is 252. 252. That's this area here, not that area there. So the green area 252, we need to add, so z squared equals 252 plus the 4. So z squared equals 256. Square root 256 equals 16. So z equals the square root of 256. Z equals 16. 4 IV. We have a box which is y by y, y by y. And inside the box we have another box which is 11 by 11. Blue area equals 203. So this is the blue area here. We need to find the whole area. So it would be y squared equals 203 plus 11 squared. 11 times 11. 11 squared is 121. Y squared equals 203 plus 121. So y squared equals 423. 324. So we need to write down y equals the square root 324. Square root 324 is 18. So y equals 18. And B says explain why x cannot be minus 15 in part 11. Part A, 1, because minus 15 is not a length. Be a bit weird, isn't it? So, next question. For each, find a positive solution and give your answer to the correct one decimal place. Now, I don't know if it'll work or not in a minute. So, 12a, x squared equals 28. X squared equals 28. If you don't have a calculator and you're using a computer, surprising, then you can always use something called a graphic calculator. No calculator, find my keyboard. Keyboard, thank you. So we've got x squared equals 28. And it's giving you a solution. Two solutions. Here we've got a positive, and we want it to one decimal place, so we can slide it in. 5.2, 5.3. So the answer is 5.3. On the other side of 5.3. So the answer is x equals the square root of 28, x equals 5.3. B. For those people who didn't want to work out the equation, y squared minus 7 equals 16, because you can't really do that on this calculator. I'm thinking, okay, where's y? It's not there. So add 7 to both sides. Y squared equals, add 7 to both sides, end up with 23. So y equals the square root of 23. So the square root 23, and the answer is, put it to one decimal place, y equals 4.8. 7 there, go next door. 4 below, leave alone. 5 or more, add 1 more. We need to add 1 more to the 7 to make 8. So the answer becomes 4.8. C. 24 equals z squared minus 15. We need to add 15 to both sides to get rid of it from that side. So that becomes 39 equals z squared. So I need to square root 39 equals z on its own. So the square root of 39. So clear, square root 39 equals sign. Press the SD key, and the answer comes as 6.24. Answer 6.24. So the answer will be 6.2. We look at the second one. 4 below we leave alone, so it's did 4, and so we need to leave it alone. So the answer will be 6.2. So z equals 6.2. Make sure you can see these answers, underline them, and D. 200 squared equals a squared plus 13 squared. You go back to that graphic calculator and you can put that straight in there. Be prepared to try and find the answer. So 20 squared, you can keep it as that, because all you need to do is put that minus 13 squared both sides. So minus 13 squared both sides. We end up with 200 squared minus 13 squared equals a squared. We keep things easy on a calculator. 200 squared minus 13 squared gives us an answer, 39831. So 39831 equals a squared. So we want the square root of 39831 to give us a on its own. So press my square root key, press my answer key, brings the answer back in from the last question, and it comes out as 199.5770. We want to one decimal place. There's the one decimal place there, 5. I will look next door, and we say 4 below, we'll leave that number there alone. 5 or more, we add one more. We add one more to the 5 to make 6. So the answer is A equals 199.6. 199.6. Okay, question 13. Remember, pause the video, look at the answers. When you're ready, press play. Electrical power can be calculated using the formula P equals V squared over R, where V is the voltage and R is the resistance in a circuit. Use this formula to complete the table below. So, we have volts, we have resistance, but we don't have power for circuit number 1. What we're going to use, P equals V squared over R. So, P equals V squared over R. We don't have power, P, we have volts, which is 5 squared, over resistance, which is 10. So, P equals 25 over 10. P equals 25 divided by 10 is 2.5. So the answer there is 2.5. 2.5. Next question. We have power, we don't have volts, we have resistance. Just remind ourselves, PV squared over R. So P is 51.2 equals V squared, we don't have, over 20. To get rid of the 20, we must times both sides by 20. Bring back in the calculator to help us out. 51.2 times by 20 equals 1024. 1024 equals V squared. Square root V 1024 gives us V. So just got the answer there. The answer is 32. So V equals 32. So we put that in here. V equals 32. How are you doing? So the first answer we got is 2.5 watts. Next one was 32 volts. Let's put the answer there. So that's watts, volts, just to say which one we've actually done. Next one, circuit 3. We don't have P. P equals V squared over R. P, we don't have volts. We do, which is 24 squared over 16. Bring back a calculator. We can do this on a calculator with one thing. So fraction key comes up, 24 squared goes there, bring down the cursor to 16, and let the calculator will do the work for us. And the answer is 36. P equals 36. So here we go, 36 watts. I'm only putting the letters in there to indicate which ones I've actually done. And it looks like the same on your table as well. So here we got power, it's 72. So P equals V squared over R. P is 72 equals V squared over 8. To get rid of this, we need to times both sides by 8. So we end up with 72 times 8 equals 576. So v squared equals 576. We need the square root, 576 for v. So square root, the answer, which was 576, the answer is 24. So the answer goes in there, 24 volts. Next one, we have voltage. No, we want voltage. We have watts. So P equals V squared over R. So 31.25 equals V squared over 20. So 31.25 times by 20. 31.25 times by 20 equals 625. So V squared equals 625. V on this occasion, 625 square root of that. So square root 625 equals 25. So the up here is 25V. So the answers, circuit 1 is 2.5 watts, circuit 2, 32 volts, 3, 36 watts, 4, 24 volts, and 5, 25 volts. Next question. Good work for you. Pause the video. Try A, B, C. Okay. I'll think of a number. I'll call it N. I add 3 to it. Add 3. I double the result. Well, let's put that round in brackets because we want to double the result. It's times by 2. And then I'll take away 2 from this result. So take away 2. I halve the result. You halve the result, divide everything by 2. Then I take away the original number I thought of. So we need n. We need to take away n. So take away n. Write this using algebra. That's it. That is A. B. Work out different values. Work out the answer for different starting values or starting numbers. So if 1 plus 3 is 4. 4 times by 2 is 8. 8 take away 2 is 6. 6 divided by 2 is 3. Minus my start number, which is 1. 2. Try another one. Say 5. Start with 5. 5. Add 3. 8. Times by 2. 16. Take away 2. 14. Divide by 2. 7. Subtract my starting number, 5, which is 2. 10. 10 add 3 is 13. 13 add 2 is 26. 26 take away 2 is 24. 24 divided by 2 is 12. Take away 10, the answer is 2. Do you get the same answers each time? Use algebra to show why this happens. So we have this expression 2 bracket n plus 3 bracket minus 2 all over 2 take away n. An expression. How can we work out to make sure it still happens? Well, first thing we need to do is multiply everything by 2. Well, if all this by 2, we end up with 2 bracket n plus 3 close bracket minus 2. And this has got to be times by 2 as well, minus 2n. And there's an equal sign really there. And that's got to be multiplied by 2 there. So there's nothing there at the moment, so it's got 2 there. What we now got is an equation. We don't really want to keep an equation. We really want to keep an expression. So get rid of the 2 here with minus 2 on both sides. We end up with 2 bracket n plus 3, close bracket, minus 2 minus 2n, which is all that, and then we take away the 2. And end up with, again, equal sign, which don't we need to put back in. So, multiply the bracket here. So 2 times n is 2n, plus 2 times 3 is 6, minus 2, minus 2n, minus 2. So simplifying through, 2n there, take away 2n, so that's nothing. 6 to take 2 is 4, take away 2 is 2. Answer, 2. No matter what number you put in here, the answer will be 2. D. Make up similar puzzles where the answer will always be the same. That's what you do. And E. Can you make one where the answer is the number that you first thought of? It's a challenge for you. There's the answers for those who need them. Thank you.